We'll be starting the webinar in just a few seconds. All right. Hi, everyone. Thanks for taking the time to join us today. My name is Tina Fabiano, and I'm on the enDAQ Marketing and Engagement team. I'm excited to welcome you to our webinar on generating interactive and customized reports in the enDAQ cloud. In a minute, Steve Hanley, our Vice President of Product, will be presenting today's webinar and Q&A session. Steve will be giving an overview of our reports function in the enDAQ cloud and how you can use it to make your vibration analysis more efficient. Using real data to demonstrate the capabilities of reports, we'll cover summarizing test data into a customizable single page, generating highly interactive shareable reports, and experimenting with custom code. In addition to Steve, we also have with us today Sam Ragusa, an enDAQ software engineer. Sam creates Python scripts to analyze and visualize enDAQ device recordings stored in the cloud. He has experience creating custom report dashboards for analysis of sensor data, so he'll be able to answer questions you have about the inner workings of the reports feature. This is a 45-minute session, and we'll have time at the end devoted to a Q&A. As you're watching the webinar, don't hesitate to use the chat feature to ask questions. You can also use the Q&A button at the bottom of the screen. Steve and Sam will answer all of your questions during the Q&A portion. We'll also have a few polls throughout the webinar for you to answer. We're really excited to be sharing all the features of our reports function with you today and answering any questions you may have. We hope you find this webinar informative and that you leave feeling as excited as we do about how this feature can help you with your analysis needs. So with all that, I'm happy to introduce Steve Hanley, who'll be taking it from here.
Thanks, Tina. Thanks, everyone, for joining. As Tina said, we're really excited to be presenting the cloud. This has been a vision for a long time. Some of you were on our webinar a few months ago when we talked about we're introducing the cloud to start. And I said, hopefully in a few months, we'll have report generation and visualization. I'm so excited we're here. And I think what we have is much beyond just a minimum viable product. We really have the ability to customize your reports, which really opens up the door to do a lot of cool and fun stuff. So here's a quick sneak peek of the reports, and I'll come back to this later on, but I wanted to at least tease it at the start. Here's an outline of the webinar we're going to go through today. I'm just going to start with laying a little bit of the groundwork on why we developed the cloud report generation, what it's useful for, what you need to use it, and then we'll get into doing some live demonstrations showing you the reports and what all the capability is in there. I'll have real data. We'll do a real test with the device here to get some live data, which is always a little nerve-wracking. And then I can show some other data we've generated reports on, which is real stuff from mining applications, shipping packages, and whatnot. We'll have some custom code too. I'll show the reports how they're customized. And then we'll end with a little bit of discussion on the cost. The report generation, there's a totally free version, which has a lot of capabilities, but then we are charging for the ability to customize with your own code. But I can talk a little bit about that at the end. And then we'll have a Q&A. If you have any questions throughout, please don't hesitate to chat them, and we'll maybe address them in real time. But if you've been on some of my other webinars, I tend to roll, so I might keep going until the very end to answer questions. We're going to start by asking a poll question here to see what our demographic is of folks in the webinar. So Tina, just pull that up. Do you currently have our devices? No, or yes, you maybe just bought some, or you have a handful you use from time to time, or maybe you're a super user and you have a lot of devices and use them pretty often. So I'll give you guys a minute to answer this. It'll help me as I go through the webinar addressing these folks here. Okay, I'll end the polling. So I'm actually kind of surprised about this. A lot of you, can I share the results? A lot of you are new to enDAQ. You don't even have one of our devices, which is kind of a pleasant surprise. I thought most of you would be customers, but then there's certainly a fair number of you that that are in that boat that have our devices and use them from time to time. All right, so why do we develop the enDAQ cloud reports? Well, when you do a test report, you need to eventually get to a summary view, a one-pager. Our CEO, you guys know me from my webinars, my blogs. I tend to talk and have a lot to share. And our CEO said to me one time, Steve, give me a one-pager. And that summarizing something in a one page tends to be difficult, but it's really powerful when you can accomplish it. And that's true with business strategy, but also test reports, and giving an idea of what happened on a test in one page for people to really understand is really powerful. And that's what we're doing with the enDAQ cloud reports. And we're letting you share that with colleagues and share it in an interactive form. There's nothing worse than getting a report from somebody and it's just this PDF and I can't play with it. I can't see and experience the data. But these cloud reports are the opposite of that. They're highly interactive. Another thing about when you're doing test analysis and generating reports, you tend to do the same set of analysis steps for a series of different tests and different data files. And they can be a little tedious to go through this export process. You run this other script over here, and then you collate some plots, and it can be somewhat tedious. So we're looking to automate that with just one single click. And then we know every test is a little different. There'll be some commonality. You want to see a frequency spectrum. You want to see some time history at a peak, things like that. But you also will want to customize. And so we really invested heavily in everything we do at enDAQ on the device side, but also in the software, and especially now with the cloud reports, to allow you to completely customize everything from how you analyze the data, how you presented it, even the colors in the plot. Everything is available to customize. So what do you need to use the enDAQ cloud reports now? Right now, they only are generated off of data from our devices. This includes, of course, our wireless devices, which we've sold over 100 of now, and it's really accelerating, which is exciting. But we've sold 11,000 non-wireless devices, and we'll continue to make and sell those non-wireless devices. So the cloud report generation works for both use cases and both data sets generated from wireless or non-wireless devices. In the future, I hope to allow cloud reports to accept external data from other sensors. And I'll show you one of the custom reports I made via an API. You can pull in any external data set. So in a way, you can use external data, but really the cloud reports are made, at least on the free version, to work from data from our devices. You also need internet access to use the cloud, as the name implies, which can be a problem for some folks. And a lot of the tools that we're putting into the cloud, like the analysis and the plots that it generates, we're also in parallel looking to publish open source versions of this so people can run things locally and get some of the cloud capability on a local machine. And as I mentioned, there is a free tier, totally free, that has most of the functionality in the cloud. We'll continue to add more and more functionality to the cloud, with the one exception of being able to customize the report with your own code. I think in the free tier, we'll still allow some customization with discrete options, like a lot of things that are customizable is you pick from a list of options. But with the starter tier and the paying tiers, you can customize, again, with your own code. So it's completely open to your imagination what you want to do. All right, this is the last slide before I get into the demo. And I just want to talk about what is the value that the enDAQ cloud reports are offering compared to our existing software tools, maybe compared to competing cloud systems out there, and then compared to maybe running things locally. So to start, we have a lot of existing software that some of you are pretty familiar with, and they run on a computer, which makes sense, and that's all good, but they only run on Windows machines. So that can be a problem sometimes. You have a Mac, if you have a tablet, you're out in the field and you want to look at some data, you can't really do that with our existing software. But the cloud now, and anyone with a web browser, including a mobile phone, can access and view data, which is pretty powerful. The other big thing the cloud report does compared to our existing software is it lets you analyze and visualize and compare multiple files at a time. Our existing software is really good at opening up one file and giving you a quick snapshot of all the data in that one file, but it doesn't let you compare two files to each other. And a lot of you sometimes are doing tests where you have trigger events. You may get hundreds or even thousands of files, And so the cloud report can help you see all that in one place. And then the other thing that I didn't really explicitly list here, but our existing software has some capabilities to do frequency spectrums and things like that, but the cloud report has a lot more. Is generating a shock response spectrum, a nice clean power spectral density, and there's some other plots that are in there that aren't available in our existing software. If we compare the enDAQ cloud to competing systems, one big thing that we've always really strove to differentiate ourselves on is the amount, the quantity and the quality of data. You know, a lot of existing wireless devices and cloud report generation tools will let you visualize maybe summary metrics across time. So you can see average acceleration levels or maybe a peak frequency over time. And we're going to give you that layer, the summary layer, but we're also behind that is all the raw data is available for processing and visualization. Another major differentiator I haven't seen in any other system out there is that we're enabling you to write your own code and execute your code in our cloud application, which I think is really unique. Again, customization with a GUI so you can select from different options is great, and we'll add some of that in the future, but it still is limited to what options we enable people to select from. Whereas when it's your own code, really the world's your oyster, and I'll show you some examples to highlight just how custom you can go. And compare the enDAQ cloud to doing something locally. You know, you may have an expert Jeff or an expert Maura at your company that's really good at doing the data analysis. And we had that, this guy, expert Jeff, we called, he was great. The problem was two things. One is if we got some test data and we wanted him to analyze it, we had to wait for him. And so he ended up being a bottleneck to get that data back from him. And so now with the cloud reports, you can still utilize the great processing ability of expert Jeff and expert Maura, but take that code that they can develop for you and then put it in your account to be able to replicate and reproduce a plot and a series of plots with just one click. So you can still get the benefit of your experts in your organization, but then not have to rely on them to reproduce test reports for future data. The other thing too is when you're using some expert to give you a test report, as I talked about earlier, that test report's going to tend to be in the form of static graphs and plots and PDFs, which are good, but you miss the interactivity. And so the cloud report that we have is highly, highly interactive. I'm really excited about it. And then of course, in the cloud, you'll have some history and a common repository of all your test reports and data. With that, let's get into a demo. So in this demo, I'm going to configure a device, a non-wireless device. I'm going to shake it using my phone, and then I'm going to view the data in our lab software, and then I'll pull it into the cloud and generate a report. So here we go. So here's our lab software. I'm going to configure the device. And again, this is a non-wireless device. It's just one of our regular S3 models. One thing is new, and you have to update. If you don't see this, you'll have to update your firmware if you have an existing device. But in the configuration, we're letting you specify a series of tags. And so these tags are going to persist in that file, and you'll see where those tags come in with the cloud report. But let's say I have a test coming up where I have two devices. Maybe I'm shipping something to California. And so on my two devices, I may put on both of them a common tag saying shipment to California, comma, inside the box, and then on one device, and then comma, outside the box on the other device. So now all the files generated with this configuration will contain those tags until I reconfigure my device. And typically when people are doing a new test, they're going to have their configuration screen open at some stage, even just to set the clock before they do the test. But this would be the time to also put in a tag of my test. So you'll be able to have all the data files contain that information, which will help in the report generation later on, as well as even filtering the data once uploaded to the cloud. Other than that, I have phone test as one tag, and then I put the serial number as another tag. I don't have any triggers. I'm just using my phone vibration, so I'm going to use just the secondary accelerometer, not the primary one. Sample of 2000 hertz, have the temperature, pressure, and light sensor turned on. So hit OK, and I'll, can you see that? I'll start recording, it's blinking, it should be. And then I'll use my phone the haptic setting to generate some vibration. Now, our phones all vibrate at 150 hertz. So you'll see why I'm mentioning that in a moment. So now I can open this recording file here in our lab software. So it connects to the computer. And I'll just quickly show you what it looks like here. Here's a recording I just did at 12:14. You see the acceleration in the X, Y, and Z. There's one particular ringtone, another ringtone, a series of different ringtones that were going. And there's a pressure, temperature, all that's in the recording file. And then here's the gyroscope as well. But that's our existing software. That's not what we're here to do. But I will highlight that the existing software opened that data real quickly and gave you all the different channels to play with here. But it didn't necessarily put it in a summary. And it didn't do any frequency analysis to start as well. So I'm going to go into my recordings, and this is where you can import data that are manually recorded or manually imported. Of course, if you have a wireless device, it can be automatically uploading the data to the cloud. But as I mentioned, you don't need a wireless device. You can import about 50 to 100 files at once. I've imported a few hundred megabyte files, even a gigabyte. It starts to get a little mad at you if you try to import tens of gigabytes at a time, as Sam can attest to. So after it's imported, you'll see that it's in the cloud. Here's a new row for this file that was just imported. And if I hit refresh, you'll see that another processing script had run and actually pulled out some summary metrics of this file. So I see basic things like the file name, the sensor type that generated it, the name of the sensor, the serial number, things like that. But I also have some process metrics, and this is available in the free tier. We show you acceleration RMS of the file, acceleration peak. We do some integration to show you the velocity, the pseudo velocity, displacement. If you had GPS, you get the GPS speed, the microphone, if you have the microphone. So all that comes in right here in this table view. And you can export this table view as a CSV. There's some other attributes that are analyzed every time you import, which includes, we will do a full power spectral density of the file and save that in the back end, a full shock response spectrum, save that on the back end, as well as picking out the time history data at the peak and save that on the back end. And the back end is available via the API, as well as when you go to generate a report. One other thing to show here is the tags. So remember, I configured my device just a moment ago, and I added the tag 9695 and phone test. So that came in when I uploaded the file. And I can filter by tags. So you can do that there. You can also, the tags are useful when we generate the reports, which I'll show in a second. So one way, and the way I recommend adding tags, is when you configure a device. But once you've imported data, you can also add a tag here by saying manage tags, create a new tag, hit create, and then hit save. And then so these new tags will be added. So that's the second way you can add tags. The third way that tags are added are programmatically. You see some of these tags are added here. That was added by our processing script. So there's a lookup table. We see, okay, acceleration peak, where did that land? And whichever range that landed in, we're going to add a tag associated with it. So that can be helpful to help filter your data, but the tags are also then what we generate alerts based off of. So with the wireless device, it's helpful to get a tag when vibration levels have changed or things of that nature. But we're not doing that quite yet. We're just going to generate a report. So here, I'm going to do a new report. You see there's a couple different inputs. You can put in the title of the report, the tags that you want of the data file. You don't have to have a tag. So you could just say, I only want to see the most recent 100 files, or the most recent one file, whatever it is, because that's the other input you have is the number. So if I put in GP drive test and 5, my report is going to pull all the most recent 5 uploaded files that contain the tag drive test. Now down here, I'm selecting which report template am I to use. There's a standard that's in free, and then there's the custom ones, and I have a few custom ones built out here. That's how you make a free one, or sorry, a new report. I already have an existing report, which I can just hit refresh. So here was one that I made on the most recent file. Now I've imported in a new file, so that test report you just saw will be updated. The test report contains 4 major figures. One in the top left is going to always be the the shock response spectrum. The middle one will be the power spectral density. And then the top one, the top right one will be a couple different things, which I'll highlight. So here's a file I just imported. You can notice a couple things. Obviously, it looks different than after when I hit refresh because there's a new file imported in my account. Here's the power spectral density. There's 4 lines for the acceleration Y. And again, this is highly dynamic. I can just isolate one of these lines. I could turn off one of the lines. I can zoom around. You name it. I can hover. You see, you get the hover location here. So you get the shock response spectrum in the top left. In the middle top, you have a power spectral density that's provided. And here, remember I talked about that our phone vibrates at 150 hertz. You see that here clearly in the power spectral density. In the top right, we're pulling in the time history around the peak. So it's the 2000 data points, I think, Sam, I forget, of the peak event. And then you see that here. And again, there's the x-axis, y-axis, z-axis, and resultant. And I should mention the table view you see where we're showing a peak acceleration level, that's of the resultant. And we have 2 accelerometers oftentimes. So which one do we decide to use? We'll use the accelerometer that's sampling faster for this. But with the custom reports, you can do whatever you'd like to do. Now on the bottom, we call this the measurement pane. And so we're plotting every single subchannel as its own subplot that we can see here. And there's 2 lines per subchannel that are sampled fast enough. There's the peak levels, and it's a absolute value, and then the RMS. So you see how that changes throughout the recording. You can zoom around, obviously. Some of these sensors like the temperature and pressure aren't sampling fast enough for us really to generate a peak and an RMS. So we'll just show you the average across the file. Here's the gyroscope. And then here's all the other files. So this is one test report. And I'm going to now going to go back to my recordings. I'll import a new file here. And to do one more example. So this file is a short one from a surgical instrument. It was actually the data you saw when I first opened the report. And again, if I hit refresh, it will do the processing. I should wait one more moment to hit refresh. It'll do the processing to pull out those peak metrics, acceleration, velocity, all that. If I come into my report, I've uploaded a new file. So when I hit refresh here, it will upload. It will pull in that most recent file, because that's what the conditions I had for this report was, just show me the most recent file. And there you go. So it looks a little different. Again, this one's kind of cool. It's some surgical instrument a customer had where it's oscillating some fixed frequency. So here it is. So this is a one file. Now I'm going to log out of my account here. And I'll show you why I'm doing that in a second. I'm going to actually close this tab altogether. Now I'm going to go back into the PowerPoint. I'm going to go through a couple more examples right now, but before I open them, I want to just explain the differences high level. So you saw in that most recent report I was just showing of one file, the top left is the peak pseudovelocity, the top middle is the power spectral density, and the top right is the acceleration time history. That's of one file. What happens if I generate a report of many, many files, which I'll show in a second? We'll do the same thing of putting a power spectral density in the middle and a peak pseudovelocity in the top left. But instead of having all these lines for all the different axes and all the different files in the account, we're going to plot a quintiles to show you the minimum, 25th percentile, median, 75th percentile, and max. You can kind of get an idea of how things change throughout the test and where normal conditions are, as well as max and worst case conditions. If you generate a report on just a handful of files, we will show you explicit lines per file, so you can compare a handful of different test conditions to one another. Now on the top right, this other example I'll pull up that I had open actually at the start of the webinar. If the file's long enough, I think we say if it's longer than 10 minutes, we're going to actually show you a rolling power spectral density. So you can see how it changed through time, which is pretty fun. And then if there's GPS data, we're going to show you a map instead of the time history. And then you saw the example of the small file. So I'm going to click this link, and all these dashboards have their own link associated to them. Now I've logged out, so I need to log back in. And once I log in, it will pull me all the way into that dashboard. And so the reason I want to highlight that is this is a way you can share a dashboard with somebody. You could bookmark a dashboard if you have a test going and it's uploading data periodically, and you could then just hit refresh and go to that page. But also if I'm generating a report for Sam, for example, I could send him this link. Now I'd have to share with him my login information, but I'd recommend you do that within an organization. In the near future, we hope to add multiple users to one account. So you could have like an admin, an editor, and then a viewer type level. But you can have, Sam and I were practicing this morning. We both were in the same account at the same time. So that's totally fine. You just have to share your login. So again, a highlight that you can share dashboards with just URL as well as the login information, and it will pull you all the way in. So here's a report that was generated off 47 different files. And as I mentioned, you still see the peak pseudovelocity on the top left where we're plotting those quintiles. So you see here, this is the median level, that green line, but some of the conditions were quite worse. And so the same thing's true with the power spectral density. You can see roughly where it was most of the time, but there's some peaks. And I want to highlight that because when I see people, they have a lot of test reports or they have a long data set, they want just one power spectral density to rule it all, which makes sense. The concern is you can really mute some events that occurred that were harsh, but when you average out the whole thing, you'll miss that. And so I think that's really powerful that we're showing you a max as well as a 75th percentile, so you can get an idea, okay, this thing is harsh, but it occurred often enough that I should pay attention to it. Now here on the top right is the time history, but there's 47 files. So if I zoom in, I see actually the time history of all those files individually. They look like straight lines, but if you zoom in, you'll see that full data set. On the bottom now, instead of showing you each sensor channel, we're basically visualizing all those metrics you saw in the My Recordings page. So you see how acceleration peak changed over time. In this particular test, this was a shipment. They had a recording every handful of minutes. There was a lot of action early on, but then throughout the test, it was pretty steady. And there you go. So there's the acceleration peak, acceleration RMS, all these metrics that you see in the My Recordings page. One thing to highlight is they're all orange because they're all generated from the same device. But if you did that example I talked about, you had two devices, all with a common tag, let's say shipment A, you would see two different colors for the two different devices as they change throughout the recording. Okay, so that's doing a standard report. Again, this is a free report off of many files. This was 47 files. Now let's see a standard report off of 4 files. So now when it's 4, we're going to show you a discrete lines per file. So this is a good way to compare them. In this particular example, it was a mining customer. They're doing some vibration testing at different locations along their hammer to see how that influenced the vibration environment. You see location 2 is the most severe, and location 3 is a little bit less severe, location 6 is a little less severe, location 7 is even less severe. So you see how that changed here in this view. Again, this is highly dynamic. You can isolate, just look at one location at a time, zoom around, all that. So when there's only 4 files or less, you'll get a line per file. These plots will be the same thing. You'll see the acceleration time history, again, 1 per file, and you'll see all those summary metrics as well visualized as a function of the recording time. Now let's go into my favorite report, which is that GPS one, as well as the one that was like 10 or 12 minutes long. So here we're showing how the power spectral density changed over time. But then on the left is the same pseudo velocity. On the bottom is the same measurements pane, but here, because there's GPS data, we're not going to show the time history. We're showing a map instead, and it's color coded based upon the speed of the vehicle. Again, highly dynamic, and these are all standard reports. Now, before I get into the customization, I want to show a couple other things that are cool about the reports. One is there's a print mode. The print mode, as the name implies, makes it better for printing. So it changes the background color to be white, and it stacks all the plots. And one thing I'll highlight too is if I'm in here and I only want to see maybe the one axis and I want to zoom in on the map right here for whatever reason, and then I go print, whatever I just changed in print mode will persist into saving this PDF. So I isolated that one channel, I zoomed in, and that came through. So I could save a PDF here, or I could, of course, print it. The other thing I can do is export this data. So I'm going to export, and it creates this JSON file. Now we have a Google Colab that we shared in the PowerPoint that I'm going to run here. If you guys don't know what Google Colab is, get ready for a lot of other webinars upcoming to show how to use Colab and Python. It's basically a Google Doc, totally free, that lets you run Python code in the cloud. So this particular Colab is going to take the exported report that I just pulled out of here and do a couple of things. So first, I'm importing some libraries. Now I'm installing the libraries. Now I'm importing the file. There we go, downloads. Okay, so now it's imported. You see there's these 4 plots that are associated with these 4 titles over here, and they came in this table view, but this isn't all that useful to you. But here, we're going to loop through those plots, and if I hit refresh over here, we're going to save 2 things. Per plot, we're going to save you a CSV file. So I can open this, and everyone knows what a CSV is. You have your nice data in Excel or whatever, so you can reproduce those plots. We're also, though, even saving a full-on HTML file, and I'll do it on this one. So you can have this, let's say over here, you love this plot, because I love this plot, this rolling power spectral density. You just want to see a big screen of this, and you want to send this to a colleague. Well, if you export the full report like I did, and then come into this Colab to pull out those discrete CSVs and HTMLs, here I now have an HTML file of that report. And this HTML file, you don't have to be logged in. It's its own file, has all the data in here, and you could share this, save it locally, and away you go. So I think that's pretty powerful. Now, back to, one last thing is in the Colab too, I can plot these plots as well. I don't have to save them if you want to see them all here. All right, now let's go back to one last standard report. Again, this is a free report again. This is data from a customer that was doing some testing on a motorcycle. You see how the vibration has kind of changed throughout the test. What they were doing is they're revving the engine. So again, in the standard report, you get the peak pseudo velocity of the whole plot of the whole file, the power spectral density of the whole file because it's short, and then the time history at the peak. But this particular application, this customer, this user really wants to see vibration as a function of natural frequency. They're revving the engine. They want to know, does my motor RPM correlate to the vibration levels? So I made a custom report here. Where is it? Where I did a couple of things. One is I changed the background color to be white. I could have changed the colors to be whatever I want, but I kept it somewhat consistent with the overall theme. Then I put in the left here a completely different plot, which is the spectrogram of the data. And you see here clearly the frequency is changing over time. And this middle plot, I kind of dove into the spectrogram and I picked out the natural frequency, the peak frequency over time. And I plotted that as its own plot. And then here, I took basically the data down here, which is the moving peak acceleration level and moving RMS acceleration level and plotted it not against time anymore, but against natural frequency. But I did a unit conversion as well. So maybe you like seeing acceleration as meters per second squared, not G's. So I did that here. And maybe you like seeing frequency as RPM and not Hertz. And so I did that here. So this was done with a custom report. Let me show another custom report. How am I doing on time? Doing pretty good on time. So here's another custom report where there's a lot of files. So here on the bottom, I didn't customize anything here. This is showing, if you guys are on a webinar I did a couple of weeks ago, I went through this data a little bit, but I had one of our wireless devices uploading data every 5 minutes, and it was on an HVAC system. That HVAC system wasn't always on. So when it was on, the vibration levels are higher. And then here's the off state. And so I can use this on and off to count basically how many times in a given hour is my system on. And then I can plot on time as a function of the calendar time in the day. And you see, the air conditioning is on as in the business hours, and it gets higher, the heat of the day, obviously. So I think that's kind of cool. And then the other thing is I can do this other layer, and I can recognize my on state and get rid of all the off state. I do this programmatically. And now I have this on state, and I can say, all right, the first 1,000 files I know are good. So I'm going to define a normal distribution of those metrics and define alarm conditions at plus or minus 3 standard deviations. And I can plot that alarm condition. And then I kind of faked a failure by moving my device closer to the fan. The vibration levels are higher. I know my system's changed. And so away you go. So that's one thing you can customize. Again, you can do some analysis in that in the custom report generation, not just change how your plots look. Now I have one more custom report, which is going to be kind of crazy, where I'm not even looking at any data regarding our devices. I'm pulling in from an outside API, and I'm going to generate this right now. If somebody wants to put in the chat some odd location, I can try to pull that in. But I'm using this API from WeatherStack to pull in weather data, and then I'm presenting that. So I'm highlighting this for a couple of reasons. One is I want to show the customization ability. Two, I want to highlight that you can correlate data from other sources to our data sets. You could even just look at data from other sources via an API. So I'm going to edit this report, and I'm going to go into my custom scripts here. So here's my weather dashboard, which I will edit. I don't know if anyone chatted out a location. If not, I will just change the location here to be Paris, France, and I'll hit save. And I'll go into my reports. I'll take my weather, and I'll hit refresh. And it will pull in now the weather in Paris. I can navigate away from this page if I do here. And in a moment, you notice up here in the top right, I got a notification. That means my report was finished. The reports will time out in 4 minutes. Oh, so Paris has nice weather. It's sunny. That's great. And so you just saw a little bit of the customization here that you can do with the custom code. Now, we also have, I'm not going to go through this. This probably deserves its own webinar for Sam and I to really dive into how you can customize it. But I want to show that the customization, the inputs into generating a custom report are two inputs. You get the files that, a list of files that contain all the attributes that satisfy the requirements of your input, which was, I want all the files with a particular tag and maybe only the most recent 10. So you'll get this files variable that will contain basically all these metrics you see in the My Recordings page, in addition to the full power spectral density, the full time history, time history at the peak, and then the full shock response spectrum. So that's one input you get to the My Reports. The other input you get to My Reports is the full URL of a file to download, the most recent one. So you could do even finer analysis on the most recent file. And so you could use that to then play with. And by the way, the point I'm trying to make here is these two inputs, the files and the file download URL, are the same thing you can get when you use the API. So you can test in a Google Colab or in a local Python environment, generating a custom report via the API, and then have literally a copy and paste into the report generation. There's a lot of helper functions that we're using here that Sam has done a great job writing. There's a lot of code here that I'm not going to go through, but one thing I want to highlight is we know this is a lot of code. We know it's a little messy. So there's a couple things we're going to be doing in the very near future. One is we're going to put all these helper functions in another library, so you can import that and have access to that with some less code. And two, we're going to even publish a more in-depth open source library to make the ability to customize some code pretty straightforward. And I'll show what I mean by that here, where I'm going to go manage custom scripts, and I'll pull in this one. So here's one of my scripts. You see here, I'm importing all the libraries, and I have all these helper functions. But if I get through all my helper functions, the part that's generating the report isn't that confusing. We have, actually, you know what I'm going to do? I'm going to do my custom one because that's a little bit simpler. Where's my mining? Where'd I put it? Oh, moving frequency. So here, if you get through all these helper functions, which again, we're going to make simpler with just a simple import, my custom report isn't, I'm making a spectrogram here, and then I'm pulling from the spectrogram some moving metrics. I'm saying my middle figure is going to be plotting the frequency versus the peak amplitude. My right figure is going to be these peaks, and again, I'm multiplying by 60 to get RPM, and I'm saying here I want the acceleration multiplied by 9.81. I'm changing my axes titles, you know, and then I'm saving this output variable of the 4 plots. So once we publish those helper functions, generating a custom report should be pretty straightforward. We'll have more webinars on that coming. So with that, I think we'll go back to the PowerPoint and have one more slide before I open it up for questions. What does this cost you? So as I mentioned, most of those reports I went through were generated with the free tier, the free report generation capability, which again is dynamically selecting what it's presenting to you based upon the data in there. So that's totally free. But if you want to customize with your own code, that's where it costs $100 a month. But you don't have to sign on for a long commitment. You could, a lot of people will do some tests. Maybe they have our devices, they're doing some tests this month. They're going to get a lot of data and want to have some test reports, but then they're going to put the devices on the shelf and come back to do some analysis maybe in a few months' time. So you could upgrade to starter to do your custom reports, then downgrade back to free. And while you downgrade back to free, you'll still have access to all the reports you previously generated. They don't go away, and you'll still be able to generate new standard reports. You just can't generate new custom reports into the upgrade again. So you don't have to commit to any time range here. It's just $100 a month for the time you're using it. You can save some money if you do a full year. You'll save 17% if you know you're going to use it a lot. One point I want to make here is we know that writing a custom report may be a little daunting for some folks, especially before we publish some helper functions and that open source library. So at least over the next few months, I'm going to offer the services of Sam and Becker and myself and our team for free. If you need a custom report, we'll be happy to help build those custom reports for you in the next few months. I don't think it'll be sustainable forever. We'll probably have to charge a small NRE to customize it for folks in the future, but at least for now, we'll do it for you for free. So please take advantage of that. And if you want to have a trial version of the starter tier, we can do that as well. This is the last poll question before you guys can ask me some questions. And now that you've seen the capability of the enDAQ Cloud reports, is this what you need? Are you going to be interested in using it? And we have given you a couple options here. No, you don't need this functionality, or you wish you could use it, but you can't use the cloud. Or yes, you like the free tier. That's good enough. I'm definitely going to use that. I'm excited to use it. Or maybe finally, yes, you're interested in potentially doing the starter tier for some customization. Okay, I'll give you guys a moment to answer that, and then you guys can go nuts asking me some questions. Okay, I will end that. I'll share the results. So we got a good range here. A few of you said, you'd like to use this, but you can't use the cloud hosted tools, which I hear. That open source library I mentioned that's going to help support the cloud would also help you do some stuff locally. So you'll in a way get some of this capability locally. And then that's great that some of you are interested in checking it out. Please don't hesitate to reach out, ask any questions now or in the future if you need some more help. So with that, Tina, do we have any questions to address?
We did get a few that came in that Sam had answered, but there are a couple that I think if you want to elaborate on them. One of them was, are there any resources for writing custom code?
It's coming. We do need to work on that. This collab, which we shared, will kind of give you an example, but we definitely need to have some more content for that. That's going to be our immediate focus in the short term. But as I mentioned, we're able to help you for free for at least in the next few months. So if you want to let us know roughly what you want to do, we can help get you a report up and running pretty quickly in the meantime.
Another question that we had was there a limit to the number of people that you could share reports with?
Now, again, you can have, the only limitation is you have to share your login, but you can have 10 people logged into the same account at once. In the future, as I mentioned, I want to create, with most cloud services, there's an organization and there's different tiers within that. So you could have an admin user, maybe an editor and a viewer. So I'll do that. We'll do that in the future. But for now, there's just one login and you can share that with any number of people. There's also no limit to the number of reports you have, which I think is nice.
Another question that we had gotten was there a limit to the number of things you could have on the dashboard?
Kind of, yeah. So we're right now explicitly showing these 4 figures. They're 4 plotly plots. So within these plots, you could have subplots like we have here. This bottom measurement pane is actually just one figure. There's just a lot of information in that. So you could do the same thing in these other 3 figures, have subplots within there. You could even explicitly make those plots bigger. So there'd be scroll bars if you do that. But for right now, there's 4 discrete plotly figures. But within a figure, you can have subplots.
And that was the questions that we had. If anybody else has anything else.
Good. I think we did pretty good on time then.
Yeah, great.
Well, if you guys have any questions that come up later as you share this with other folks, don't hesitate to reach out to myself, Tina, Sam, our customer success team, and we can be happy to help you here. As I mentioned, this has been a focus for a long time. We're really excited to roll it out, and I'm really invested to get people using it. So please take advantage of that and ask me for help, and we'll be happy to give it.
Thank you guys very much. And thank you everyone for attending today and for your great questions. We hope you found this webinar helpful and informative and that you're ready to experiment with and use reports in the cloud. Like Steve said, if you have any other questions or think of something later, don't hesitate to contact us. We'll also send out an email in the next few days with a recording of this webinar and some links to some of the helpful resources. And if you'd like a more in-depth overview of the different functions or features of the enDAQ cloud, you can always book a demo with one of our engineers who will walk you through your specific questions. But again, from all of us at enDAQ, thank you so much for joining us today.
Thank you, everyone.